Let me show you the single upgrade that turns a chatbot into something that can actually get things done. Because on its own, even the smartest language model has a strange limitation. It can think brilliantly about the world, but it can't touch it. Ask it what the weather is right now, and it can't know. Ask it to send an email, book a meeting, or check today's stock price, and it simply can't. It's a mind with no hands. It was trained on a frozen snapshot of the past, and it lives sealed inside a text box. All it can do is read what you write and write something back. Astonishing text, but text is where it ends. And that's a real problem, because most useful work isn't just talking, it's looking something up, running a calculation, saving a record, calling another system. A brilliant assistant that can only describe actions but never take them is stuck behind glass. Think about your own workday. How much of it is pure thinking versus looking things up, opening an app, sending a message, checking a number? Almost everything useful involves reaching outside your own head. For an AI, reaching outside its own head is exactly what it cannot do until we build it away. So we give it hands, we give it tools, and the mechanism for that, called function calling, is one of the most important ideas in modern AI. It's the difference between a model that talks about the world and an agent that acts in it. This is the tools layer from my video on agentic design, opened all the way up. Let's build it piece by piece and watch a language model reach out and act for the very first time. Part 1. What is a tool? The word sounds technical, but the idea underneath is simple. A tool is just a function the model is allowed to ask for, a small, specific capability, living outside the model, that it can call on the moment it needs to. If the model is a brain, a tool is a single, well-defined thing that brain can make happen in the outside world. And the range is huge: a search tool to look something up on the live web, a calculator for arithmetic the model shouldn't trust itself to do in its head, a database query to fetch a customer's real, current order, a send email tool, a run code tool, a tool that reads your calendar. Each one is a door out of the text box into something the model could never do on its own. Crucially, the model doesn't invent these, it's handed a menu, a specific, limited set of tools that whoever built the system decided to make available. 3 tools or 30, the model can only ever reach for what's on that menu and nothing more. And notice what tools really change. They don't make the model smarter. Its reasoning is exactly the same. What they change is its reach. A tool doesn't improve the mind, it extends the arm. That's a distinction worth holding onto, because it explains both why tools are so powerful and why they can't fix a model that reasons badly. This is the tools block from my agentic AI video, the one that sat beside the model with arrows running both ways. Now we can see what those arrows really are. Each one is the model reaching out to a tool and a result coming back. But here's the part that trips everyone up. When the model uses a tool, it doesn't actually run it, not directly, and understanding why is the key to the whole thing. Part 2, the trick behind it all. It's tempting to imagine the model reaching out and running the tool itself, but that's not what happens, and the real mechanism is cleverer and safer. When the model decides it needs a tool, all it actually does is produce a special piece of text, a structured request that says, in effect, please run the weather tool with the city set to Tokyo. That's it. The model doesn't fetch anything, it just asks. That request goes to the system around the model, the actual software of the application it's running inside. The system reads the request, runs the real weather tool, gets the answer, and hands the result back to the model as a new piece of information. Then the model carries on, now knowing the weather. Think of the model as a chef calling out an order, and the system as the kitchen that actually cooks it and brings it back. And this split is the entire trick. The model decides what it wants. The system decides whether and how to actually do it. The model never touches your database, your inbox, or your bank account directly. It only ever asks. A trusted layer in the middle does the real work and can check, log, or block any request before it runs. That separation between asking and doing is what makes the whole thing safe enough to trust. So the model asks in a structured way and the system acts, which raises the obvious question: how does the model know which tools exist and exactly how to ask for each one? Part 3, the instruction manual. For the model to ask for a tool correctly, it needs a description of that tool. This description is called a schema, and it has three simple parts. First, a name like get weather. Second, a plain language description of what the tool does and when to use it. Get the current weather for a city. Use this whenever the user asks about weather. And third, the parameters, the inputs the tool needs, in this case a city, as text. That middle part, the description, matters far more than it looks. It's a tiny instruction written for the model telling it precisely when this tool is the right choice. Give it a vague description, and the model reaches for the wrong tool at the wrong moment. Give it a sharp one and it chooses well, again and again. An enormous amount of an agent's reliability comes down to how carefully these little descriptions are written. And notice where this lives. These tool descriptions sit right inside the system prompt, the instructions layer from my last video. The menu of tools and the guidance on when to use each is part of the standing brief the model reads on every single turn. So the model has a menu, each item with a name, a description, and its inputs. It knows what it can ask for. Now let's watch it actually use one, in the loop that powers every agent. Part 4, the loop. Here's the single most important pattern in all of agentic AI. Once a model has tools, it stops answering in one shot and starts working in a cycle. 3 steps repeated. Step 1, think. The model looks at the goal and at everything it knows so far and decides what to do next. Can it answer already? Or is it missing something it can't get on its own? Maybe it needs to look a fact up or run a calculation first. This is the reasoning step, the model planning its very next move. Step 2, act. If it needs a tool, it makes that structured request we just saw. Call this tool with these inputs. The system runs it. This is the model reaching out and touching the world. Step 3, observe. The result comes back, a search result, a number, a database row, and lands in the model's context as new information. Now it knows something it didn't a moment ago. Then it loops. Think again now with the new information in hand. Act again if it still needs more. Observe again. Round and round, search, calculate, look up, check, until the model decides the goal is finally met and it's ready to give its answer. Think, act, observe. That quiet little cycle, turning as many times as it takes, is the heartbeat of every single AI agent. And this is why an agent can tackle problems a one-shot answer never could. A hard task becomes a sequence of small steps, each one informed by the results of the last. It's not thinking harder. It's thinking, then checking, then thinking again, the same way a person works through something genuinely difficult. Let's make all of this concrete, because the loop really clicks when you watch it turn once. You ask your assistant a simple, everyday question. What's the weather in Tokyo and should I pack an umbrella? To you, it's one question. To the agent, it's a tiny project, and it's about to take itself through 3 steps to solve it. Think. The model reads your question and realizes something. It can reason about umbrellas all day, but it has no idea what the weather in Tokyo actually is right now. It needs data. It needs the weather tool. Act. So it produces the request, call get weather with city set to Tokyo. The system receives this, calls the real weather service, and gets back the facts, 16 degrees and raining. Observe. That result, raining in Tokyo, drops into the model's context. And now everything changes because now it actually knows. The umbrella question isn't a guess anymore. Think one final time. It now has the weather, it has your original question, and it has everything it needs, so it answers. It's 16 degrees and raining in Tokyo right now, so yes, definitely bring an umbrella. Notice exactly what happened there. Live facts it couldn't have known, folded into a genuinely useful answer, from a model that, left on its own, knew neither the weather nor what to do about it. One question, one tool, one turn of the loop, but real assistants have many tools. So how does the model choose the right one? Part 5, choosing among many. A serious assistant doesn't have one tool, it has a whole toolbox. Search, calendar, email, database, calculator, and more. And on every think step, it has to pick the right one or none at all. How does it choose? Mostly from those descriptions. The model matches what you're asking for against what each tool says it does and reaches for the best fit. Ask about a meeting, it leans toward the calendar tool. Ask for total, it reaches for the calculator. The descriptions are the signposts. But there's a catch, and it comes straight from my video on context engineering. Give a model too many tools with overlapping or fuzzy descriptions and it gets confused. It picks the wrong one or hesitates or reaches for three when it needed none. Every tool description also takes up room in the context window, crowding out everything else. More tools is not always better. A small, sharp toolbox almost always beats a giant, cluttered one. So with clear descriptions and a focused set, the model usually chooses well, but usually isn't always. So what happens when a tool call goes wrong? Part 6. When things break, tool use sounds clean when it works. But in the real world, tool calls fail, and a good agent has to expect it. There are a few classic ways things go sideways. The first is bad inputs. The model asks for the weather but spells the city wrong or leaves out a required field. The tool can't run and returns an error instead of an answer. The model has to read that error and try again correctly. The second is reaching for a tool that doesn't exist. Under pressure, a model can sometimes invent a tool it wishes it had, asking to call, say, a book flight tool that was never on the menu. A well-built system catches this and tells it that tool isn't available. There's a third, subtler failure too. A tool comes back with far more than the model needs, a giant blob of data, and it clogs the context window, burying the useful part. This is why serious agents don't just dump raw tool results back in. They trim and summarize what comes back so each observation stays clean. It's context engineering happening inside the loop. And this is where good agents truly earn their keep. When a tool returns an error, the model shouldn't just give up, and it absolutely shouldn't pretend the tool worked and make up a result. It should notice the failure, understand what went wrong, adjust and try a different approach, fix the input, pick another tool, or tell you, honestly, that it couldn't. Handling failure gracefully is a huge part of what separates a reliable agent from a fragile toy. So tools can fail and a good agent recovers, but there's a deeper issue than failure. Some tools don't just read the world, they change it, and that changes everything. Part 7. Tools that act. There's a quiet but crucial line running through every toolbox. On one side, read tools. On the other, write tools, and the difference matters enormously. A read tool just looks, search the web, check the weather, read a document, look up an order. If it makes a mistake, the worst case is a wrong answer. Nothing in the world actually changed. These are safe to let the model use freely. A write tool acts, send the email, charge the card, delete the file, place the order. When one of these runs, something real happens out in the world, and it often can't be taken back. This is a completely different level of risk. A model that can browse the web is convenient. A model that can move money or email your customers on its own is powerful and, if you're not careful, genuinely dangerous. Which is exactly why these tools sit behind guardrails, the subject of an upcoming video. For the risky ones, serious systems put a human in the loop. The model is allowed to propose an action, send this email, but a person has to approve it before it actually happens, the model suggests. A human or a strict hard-coded rule signs off. The more a tool can change the world, the more carefully its trigger is guarded. Read tools to perceive, write tools to act, and careful controls on anything that touches the real world. We've built the whole tools layer. Let's step back and see the complete picture. Here is what tools really are. Hands for mind that could only think, a menu of functions the model can ask for, a clean split where the model requests and a trusted system acts, and a loop think, act, observe that turns over and over until the job is done. And this is the exact moment a language model becomes an agent. In my video on how LLMs work, we saw a model that does one thing, predict the next piece of text. With prompt and context engineering, we learned to steer what it sees. With instructions, we gave it a job and a personality. And now, with tools, we've given it the ability to act. That is the whole leap from a clever machine that describes the world to one that reaches out and changes it. And if you remember one thing, make it this. The model never really touches the world directly. It only ever asks. Every search, every email, every action passes through a request and a system that decides what to actually do. That gap between asking and doing is where all the power and all the safety of AI agents lives. And every other block still to come in this series plugs into this loop. Memory decides what the agent carries between the turns. Planning decides the order of its actions. Guardrails watch what it's about to do. Multi-agent systems are really just agents calling other agents as tools. Once you can see the think-act-observe loop, you can see the shape of everything else. A mind, hands, and thoughtful control over how it uses them, and you get something genuinely new. If this made function calling finally click, give it a like, it really helps the channel. And subscribe, because next we look at memory, how an agent remembers across a long task and even across sessions. We're building AI up from the ground, one blueprint at a time. Thanks for building it with me. See you in the next one.